All right, you guys, let's do a recording here for reviewing chapter 6 here. So put some stuff together, and this will be review kind of following the back of the book on page 452. But again, we're going to take this in two parts. So starting with the first lesson, we have law of sines. Let me get the pen working here. All right, when do you use law of sines? We said you're going to use it with angle, angle, side, angle, or when you know two sides and a non-included angle, which is that side, side angle special case. So if I have a problem like this, I'm going to draw a picture too. Angle B is 72 degrees, angle C is 82 degrees, and little b is 54. Now I can tell that I got two angles and a side. I don't know, it's not the included side, but we can draw the picture now. So if I draw the picture of this, and if I put the 82 there, then that's the C, and I'm going to put the 72 right here, so that's the B, and so then this little b is 54. Now to find the other parts, this would be little c and this would be little a. Well, first of all, angle A is going to be easy because if you know two angles, you automatically know three. So this is one solution, 72 plus 82, and 180 minus, you're going to get this to be 26 degrees, okay? So now you need to find little a and little c, okay? So I can use law of sines. So I do sine of 72 is to its opposite side 54 as sine of 82 is to its opposite side little c. So you guys cross product here. Sine of 82 times 54 divided by sine 72. And if you check that right now, you should get 56.2. Again, sine of 82 times 54 divided by sine 72. And then to get the little a, sine of 26 is to its opposite side, little a, and you could pick either one. I'm going to pick sine of 72 is to 54. And this time you take sine 26 times 54 divided by the sine of 72 degrees, and you get 24.9 rounded to the nearest tenth. Okay, so that's how you do angle side or angle side angle. You can see it's angle, angle, side, but then once I find this angle, you could use angle, side. It's the same. All right, let's do a side, side angle. So here it says angle B is 150, little a is 10, and little b is 3. Now this one was in the book. Now, red flag goes up right here. Red flag, I didn't color it red, but if angle B is 150, that's an obtuse angle, and the little side B is opposite that, that can't happen in a triangle. Angle A has to be bigger than angle B if the side opposite is longer. Now, if I went ahead and, excuse me, and did the sine of 150 is to 3, as the sine of angle A is to 10. If you do the math here, you're going to get sine angle A equals a number bigger than 1. So the sine of 150 actually is a half. Half times 10 is 5. So here you're going to get 5/3. And when you do the inverse sine, it's going to give you an error. Well, no triangle exists. No triangle exists. No solution to this problem. So you can kind of check ahead of time. All right, so what if you get one of those that's like this? So angle B is 25 degrees, little a is 6.2, and little b is 4. Okay, so if I try to draw this picture now, I'm going to make this 25, and this is 4. And then a is going to be 6.2. I'll put that there, so this is a. And so b goes there, and we know c's got to go up there, so this is going to be little c. All right, so it's side, side, non-included angle. So I do sine of 25 is to its opposite side, as sine angle A is to its opposite side, 6.2. All right, so now if I cross product here, I take this times this, sine of 6.2 times the sine divided by 4, and I get sine angle A equals 0.6551. Now I do inverse sine of answer, and I end up getting, for this one, 40.9 degrees. But sine is also positive in quadrant 2, so I have to take 180 minus that, guys, and I get 139.1 degrees. Now, the reason that there's two solutions here is the 139.1 plus the 25 is going to be less than 180, so this is one of those two triangles exist. All right, so how do you finish the problem? Well, this was angle A twice. So if this is angle A and this is angle A, then the other angle C is going to be 25 plus 40.9 and then subtract from 180 and you get 114.1. This angle C would be 139.1 plus 25 and subtract, and here you get the smaller angle of 15.9. Now you have to finish the problem because you still have to find little c. Okay? First of all, angle and shoot. Yeah, that's right. So we have all three. This is angle A, angle B, angle C. So now you need to find little c to finish the problem. So if I go off to the side here and I do sine of 114.1 is to little c as sine 25 is to 4. Here I get little c to be 8.6. Sine times this divided by sine, and you get that. The other one, if I do sine of 15.9 is to little c as sine of 25 is to 4. Here little c turns out to be 2.6. So there's a case where you have two solutions. Okay, kind of finishing out lesson 1 now. If you are given a problem like this, angle B equals 80, A equals 4, and C equals 8, and you draw a picture of that. So here's my 80-degree angle, here's the 4, and here's the 8. This is the side angle side. Now, the question wants to know the area. So on the bottom of your formula sheet, you have a formula that says 1/2 AC sine B. Now, I know A, C, and the angle in between is B. So angle B is between A and C. So then this formula just goes 1/2 of 4 times 8 times the sine of 80 degrees. And when you do this, you get the area equal to 15.76 units squared. So that was all lesson 1. Law of sines and then finding area. Okay, now we get into lesson 2, law of cosines. When do we use law of cosines? Side, 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 side angle, side. Now, law of cosines will produce an answer. You don't have to worry about the two triangle type things. It will always produce an answer. So let's start out with this one. Little a is 6, B is 9, and C is 14. That's the side, side, side case. Now, the way the law of sines work, you always want to, and I think you should probably try to find the biggest angle first. So it's got to be opposite this. So, I didn't draw a picture, but if I did, I'll make this 14, this 9, and this 6. So this is going to be my C up here. So all three law of cosines, you have to isolate the angle or the side opposite that you want to find the angle of. So I'm going to write 14 squared equals 6 squared plus 9 squared minus 2 times 6 times 9 times the cosine of angle C. Now be careful with your math here. This is 196, 36, and 81. That adds up to 117. And this is 2 times 54, so that's minus 108 cosine angle C. Now you can't combine these because that's a variable. So you move the 117 over here, and you end up getting 79 equals negative 108 cosine angle C. So cosine angle C is going to equal 79 divided by negative 108. So I know that because this is negative over here, this is going to be an obtuse angle. So you do the inverse cosine of 79 divided by negative 108, and that angle C turns out to be 137 degrees. Now, once you find that, you can use law of sines. So I do sine of 137 is to 14 as sine of angle B is to 9. And I don't have to worry about two solutions because I already have my one obtuse angle. And you solve this and you get angle B to be 26 degrees. And then you do the 180 minus thing, and angle A is going to be 17 degrees. Okay? So that's using side, side, side. Now maybe I can kill two birds with one stone here. Here's a parallelogram. And so this is going to be 10 and this is going to be 6, and they're going to give you this angle to be 70 degrees. Let's find this diagonal. So isn't this a side angle side case? So I'm going to solve for diagonal 1. So diagonal 1 squared, remember that's a squared, equals 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of 70 degrees. You can do this all in one step on the calculator. If you go through and do this, you get this to be 94.96, and then take the square root, and you get this to be 9.74. Now, what if you're asked to find the other diagonal, which would be this one, D2? Remember, if this angle is 70, this one up here is its supplement because the consecutive angles are supplementary. So now you do the same thing, the 6 squared plus the 10 squared minus 2 times 6 times 10. Now put the 110 in there. And this, because that's a negative minus a minus, this is going to end up being D2 squared is going to end up being 177, and D sub 2, the other diagonal, is going to be 13.31. So side angle side, you can just do the whole thing in one step, and you go from there. Okay, let's do one word problem, and this is actually number 38 in the review, and it kind of talks about navigation and bearings. So two planes are leaving an airport, so I'm just going to put a dot right here. And one's going 425 miles per hour, and it's going to end up being 2 hours. And the other plane is going 530 for 2 hours. So, guys, I think this would be 850, and this would be 1,060 for the distance traveled. Now, the one is going at a bearing of 355. So that's degrees clockwise from north. So instead of going straight up, this thing's going to go 5 degrees on this side of it right here. So that plane's going to be right there, and this is going to be 5. Now the other plane's going at a bearing of 67 degrees, so it's going to go clockwise 67. So I'm going to put that right there as 67. Now I want to find the distance between the two planes. So here's plane 2. Now 425 times 2, this is the 850 miles that that plane traveled, and this one went 1,060. Now you got to be careful here because you got to take the 67 plus the 5. So that whole included angle there is going to be 72 degrees. Now to find D, isn't it law of cosines? You have side angle side. So you go in and you work on this, and you have so 850 squared plus 1060 squared minus 2 times 850 times 1060 times the cosine of 72 degrees, and this is what D squared equals. And I ended up, when I got the answer, I got D is equal to 1,135.5 miles. So see if you can get that one to work for you. And then lastly in this lesson, let's do Hero's or Heron's formula. This is to find area if you know sides, all 3 sides. So let's suppose A is 15, B is 8, and C is 10, okay? So we're looking at this triangle. Now, Heron's formula looks like this. K is equal to the square root of S S minus A, S minus B, S minus C, where S is equal to 1/2 of the perimeter, A plus B plus C. So if I add 15 and 8, 23, 33, so S is going to be equal to 1/2 of 33, which is 16.5. So I simply go to the formula, I put in 16.5, do 16.5 subtract 15, 1.5, 16.5 subtract 8, 8.5, and 16.5 subtract, which is 6.5. So I multiply all four of those numbers, take the square root, and you should get 36.98, whoops, 36.98 units squared for your area. So that pretty much covers lessons 1 and 2. Okay, and I'm just going to do one more lesson and then we'll stop the video here. So 6.3 now is on vectors. Sorry about the pop-up there. So the vectors, now, when you talk about the component of a vector, how do you get from this point to this point? And that's how you draw it. But you got to go from point A to point B, and you want to be able to, again, so if the component form of the vector, let's say A here was -2, 1, and this up here was 4, 6, the ordered pairs. Okay, what's the vector component? Well, how do I get from -2 to 4? I go right 6. How do I get from 1? So this right here, less than, greater than, this is the component. Okay, now the magnitude of the vector would be written like this, or if I called this u, it would be the magnitude of u. You just take 6 squared plus 5 squared, 36 and 25, and you take the square root, and you get the square root of 61 for your magnitude. So that's how you do components now if you're given 2 points. All right, now what about if you're given a vector u, and its component form is 3, 5, and they want you to find the magnitude, and they also want you to find the direction. Okay, so to find the magnitude of u, it's simply going to be the square root of 3 squared plus 5 squared. So I end up getting square root 34. Now if I'm looking at this right here again, over 3 and up 5, this is 3 and this is 5. If I need to find this angle theta right here, it's inverse tangent of 5/3. And if I do that on the calculator and make sure I'm in degree mode, that's approximately 59 degrees. So if I did root 34 cosine 59 degrees plus, and I put this in parentheses, and I do sine 59 degrees. If I take this times this, I'm going to get back to 3, and this times this, it's going to get back to 5. Okay, then what about if you're given the magnitude of something like a vector and it's 8, and you're given its direction is 120 degrees, and they want you to come up with a component? So let's draw a picture of this. So the vector is going 120 degrees, and the length of that right there is 8. So I draw this down right here. Now if that's 120, guys, isn't this 60? Okay, so if you take r cosine theta, you're going to get the x, and r sine theta, you're going to get the y, or the a and the b if you're using vectors. So if I take 8 times the cosine of 120, I end up getting -4. And if I take 8 times the sine of 120, again in degree mode, I end up getting a decimal, but I know the sine of 120, again, is root 3 over 2, so this is negative or positive 4 root 3. So in a 30, 60, 90, that's 4, and that's 4 root 3. So my component of this vector is -4, 4 root 3, and that makes sense because that's quadrant 2, negative, positive. Okay, I'm going to do one more problem. Okay, this is a little bit trickier now. This is problem 75 in the assignment. It talks about, so you have one forces with magnitudes of 85 and 50. So I have an 85-pound force and a 50-pound force. And they act at a single point, and the angle between is 15 degrees. So here we go. I'm going to make this force 50 pounds. Now, the force, excuse me, this is also the magnitude of that vector, so that's the length, 50. Now, the other one's going 85, and that's also the magnitude. All right, so can't I, if I put this right here, I can make that vector component 50, 0. Now, this one's going to be 85 times the cosine of 15 degrees and 85 times the sine of 15 degrees. And if I do that properly, this ordered pair up here becomes 82.1, and then the second value here is 22. Now the resultant is also the diagonal of the parallelogram. So if I kind of go here and here, I'm looking for the length of that vector right there. All I have to do is add the 82.1 plus the 50. So I get that vector to be 132.1, comma, and 0 plus 22 is 22. So this is the component of that vector. To find the length of it is finding the magnitude. You have to square this plus this squared, add them up and take the square root. And then when you do that, you get 133.92 pounds. So there is your resultant vector for that. Now, this should review everything that's on part 1 of the test. And hopefully you guys use this now. And we'll